Hello students, this is the last topic in this particular module, Poisson Variate generation. So a Poisson distribution variable n with mean alpha greater than 0 has the PMF P of n is equal to e power minus alpha into alpha power n divided by n factorial, where n is 0 to whatever number given. So what is the procedure for generating a Poisson variate n is step 1, set n is equal to 0, p is equal to 1. Step 2, generate a random number r of n plus 1 and replace p by p into r of n plus 1. Step 3, if p is less than e power minus alpha, then accept n as n, small n, then go to step 1. Otherwise, reject the current n, increase n by 1 and return to step 2. And upon completion of step 3, p will be multiplication, that is pi of ri, where I is between 1 and n plus 1. And if p is greater than or equal to minus alpha, then n is rejected and the generation process must proceed through at least one more trial. If n is equal to small n, then n plus 1 random numbers are requested. So the average number is given by e of n plus 1 is equal to alpha plus 1. So let's go with an example. Generate 3 Poisson variates with mean alpha is equal to 0.2 for the random numbers, r is equal to 0.4357, 0.4146, 0.8353, 0.9952 and 0.8004. So given alpha as 0.2, so e power minus alpha is equal to 0.8187 if you calculate. So step 1 will be set n is equal to 0, p is equal to 1 initially. Step 2 will be generating a random number r of n plus 1 and replace p by p into r plus 1. So let's do that. R1 will be the first number what they have given for 4357, 0.4357. P will be p into r of n plus 1. So p will be p, that is previous value 1 into r of n plus 1. So r of n plus 1, initially we have kept n as 0, so r1. So p will be 1 into r1, that is 4357. Next, if p is less than e power minus alpha, then accept n is equal to small n. So what is p? We have just now calculated 0.4357 and e power minus alpha is 0.8187. So since 0.4357 is less than 0.8187, accept n as 0. That means 0, and then again you have to go to step 1. So small n will be 0, p will be 1. So R1 will be now since you have taken n is still 0, let's move on, try with the second random number. So R1 will be 0.4146, P will be 1 into R1, that is nothing but that is P is equal to previous value into R1. So 0.4146. Step 3, again now check P1 is, P is 0.4146. E power minus alpha is 0.8187. So since p is less than that, accept n as 0 itself. Then again go to step 1. So set n is equal to 0, p is still 1. Now we will take the third number as the number here, that is r1 here. So r1 will be try out with the third number, 0.8353, p will be 0.8353. So now p is 0.8353. E power minus alpha is 0.8187. So P is greater than E power minus alpha. So reject n as 0. That means you should not accept it. Return to step 2 with n is equal to 1. That means you're replacing n is equal to 0 with n is equal to 1 now. So n is 1. Generate a random number r of n plus 1. Replace p with p into r of n plus 1. So now n has become 1, r2. Now r1 is this, r2 becomes next number 0.9952. P will be r1 into r2. That means the previous value was r1 into r2. So 0.8353 into 0.9952, that is 0.8313. Now, so P has become 0.8313. So Since that is greater than 0.8187, again reject n as 1, return to step 2 with n is equal to 2. So the new value of n is 2. Generate a random number, replace it with this. So R3 now will become 0.8004. P will be R1 into R2 into R3. So that becomes 0.6654. So since it is less than e power minus alpha, accept n as 2. So all the numbers are done with. So the summary will be when n is 0, what was happening? Again, it was accepted. So second step, again it was accepted. Then n was still 0. Then it got rejected. So n became 1. So it got rejected, n became 2. And then it got accepted. So this is one example of Poisson variate generation.